Okay, so here's the review for the 7.1 to 7.2. The first one, inverse cosine of 0. First off, just make sure you're in radian mode when you're checking your answers. Remember, some of them may show up perfect, some you have to work towards. So make sure, again, you're in radian mode like this. So if you do cosine -1 of 0, that gives you 1.57. So that's what we're going to be working towards. We do need an exact answer, and so let's think through this. So if it's cosine -1 of 0, that means that cosine of theta is equal to 0. And remember, that means x equals 0 because cosine relates to x. And so when x is 0, you're either up here or down here where it's 0, 1 or 0, -1. And this place is pi halves, this place is 3 pi halves. Remember that sometimes we'd have to use negative pi halves because that's coterminal with this. But in this case, we're doing inverse cosine. And remember, the interval for inverse cosine is upstairs, so to speak, in quadrants 1 and 2. And so that's going to be pi halves for our answer. And you can double check that by doing pi halves. Pi divided by 2, and the decimal matches. So on all these, the decimal should match to whatever your answer is. So remember, cosine -1 was quadrants 1 and 2, but we said sine -1 and tan -1, the intervals over here. Now, just as a side note about that, if you're like somewhere here, don't put something like 7 pi 4s. Instead, you'd need negative pi 4s, because you have to go from negative pi halves to pi halves. So that's just on some other problems, but you can't put something over like pi halves, and so it'd be from negative pi halves to pi halves, and so you'll need the negative of whatever the reference is. Okay? Alright, then this one is tan -1 of square root of 3. So trig tan -1 square root of 3. This gives you 1.047. And so that's what we have to work towards. So if we have tan -1 is square root of 3, then that means tan theta equals square root of 3, because these are equivalent. If you really wanted to, you could even say theta equal this, but then we don't really usually write that. We just start with tan theta equal that. So that's how the equations are related. Okay? Theta is the inverse tangent, so then we can say tan theta is this. And so then we think of it as square root of 3 over 1. And you got to remember all your information related to trig, like tan was y over x. And so when we think about our ordered pair xy, we're going to think 1 and square root of 3. But those don't show up on your unit circle. We need to put divide by 2 for both of them, and that's going to be at pi thirds. So at pi thirds, that's going to be our answer. If we do pi divide by 3, we get 1.047. Any questions about that? Okay. So then the next one says cosecant negative 1 of negative 2 square root of 3 over 3. And we got negative 1.047. And so if you want to, just think, well, if this was positive, then this is going to be negative. That's the easy way to do it, but that's kind of a coincidence. So I'm going to work it out. So what I would say is you have cosecant theta equal to negative 2 square root of 3 over 3. And what we're going to do on this one is work backwards and flip both sides, because cosecant and sine are related. Remember that cosecant is 1 over sine. And so if I flip this side, we'd have sine theta. And also, again, thinking about working backwards, this is the rationalized form of it. And so the unrationalized form of it would have been negative 2 over square root of 3. So how you can remember their equivalent is you would multiply by square root of 3 over square root of 3 and end up with this. So if you work backwards that way to simplify it, then all we need to do is flip it, and so we get negative square root of 3 over 2. So then we got to think, where is sine negative? Sine is negative where y is negative, so that'd be down here and down here somewhere. And so this one would be where it's 1/2 negative square root of 3 over 2, and this one would be where it's negative 1/2 negative square root of 3 over 2. Because remember, the half and the square root of 3 over 2 go together on the unit circle. And so this one with the half would be at 5 pi thirds. And this one would be at 4 pi thirds. So we know that sine was only, like sine negative 1 is only available in that, and so cosecant negative 1 would also just be in that interval. So then you're going to think your answer is 5 pi thirds, and you're very close. You have to find the coterminal. Find the coterminal, and so then that's going to be negative pi thirds. And that's what we end up with. So basically think of going 5 thirds minus 2 on your calculator. And that's negative 1/3. And so then you get negative pi thirds. So basically, like I was saying up here, on a side note, if you get 7 pi fourths, you're going to need negative pi fourths. Well, it's the same thing here. If we get 5 pi thirds, then it's really going to be negative pi thirds. Any questions about that? Okay. All right. So on our next one, we've got cosecant negative 1 of negative 7. Again, we're in radian mode. Cosecant negative 1 of negative 7. That's negative 1.43. Sorry, I did this backwards. Negative 0.1433. And we want to the 100th, which means we want 2 decimal places. So based on this 3, we're going to round down and just get negative 0.14. So we just round to 2 decimal places. Any questions? Okay, this one is one of the ones where you have 2 different types of trig functions which are not the same. And so the inside basically is going to tell you your location of your triangle and the quadrant. So we work inside out. So we call this tan theta equal 1. That would happen where it's the same value for y and x, like square root of 2 over 2 for both of them, because tangent is y over x, and so they'd cancel out, and that happens at pi fourths. And it also happens over here at 5 pi fourths, where both are negative. And what we're going to want is the pi fourths because of the location. Because tan negative 1 is defined here. So that means our answer to the inside is pi fourths. And so then what we do is we have cosecant of pi fourths So we have to get our inside answer first. Remember, just like when we were doing composite functions, we had to work inside out when it was f circle g. When it was f circle g, we did f of g of x, and we had to do g first. So that's the same thing here. Okay, so now cosecant of pi fourths. Okay, so remember, like we did earlier, cosecant was 1 over sine. And what I'm going to do for this is I'm not going to flip both, because that'd make 4 over pi, which is weird. I just want to say sine of pi fourths, which again is the y value. So we get square root of 2 over 2. And again, thinking about if we go backwards, it would have been 1 over square root of 2. And then for cosecant of pi fourths, we want to flip it, and so we get square root of 2 over 1, which is just square root of 2. So on this one, if we did cosecant of inverse tangent of 1, we get 1.414. And if we do square root of 2, that's also the 1.414. And so that's how you know you did it right. Any questions about that? Okay. So then this one is the kind on 7.1 where you have the exact same trig function, just one of them's an inverse. And so on this type problem, you don't use your triangle or the Pythagorean theorem. You basically guess and check. And so what we would guess and check would be 5 pi eighths, both positive and negative. We would also say our denominator minus our numerator coefficient, so to speak, coefficient for pi. 8 minus 5 is 3, and so we're going to try plus and minus 3 pi eighths. So we want to try 5 pi eighths and we want to try 3 pi eighths. Okay, so sine -1 of sine of 5 pi over 8. That gives us 1.178. And when we do 5 pi over 8, we get 1.963, which is too big. So then we try 3 pi over 8. Which is 1.178, which is what we wanted. And so then our answer is 3 pi over 8. Any questions on that? Oh, by the way, as always, you could work on your Math Excel review and try to make at least 80 for an extra 3 points. Okay, so we have 3 pi eighths. Any questions on 6? Okay. On number 7, this is one where you're trying to find the inverse and get your range of the original, your domain of the inverse, and your range of the inverse. I know some people on the worksheet kind of did the wrong thing here. They put infinity. So I'm going to show you how we can just get it real simple. This is equivalent to 0, pi sevenths. And that's your domain of the original. The domain of the original is the same as the range of the inverse. So I'm going to say do this first. So that's 0, pi over 7. Before I even get the inverse, I know the range of the inverse. Okay? And then also, this is a -2 of something, and there's no plus or minus anything. And so that means our amplitude would be the absolute value of -2, which is +2. So our amplitude is the number in front, and it has to be positive. And so that means this has to be from -2 to 2 for both of these. So I still haven't even gotten my inverse yet, but I know that this range and this domain are the same. And it's just based on the number in front, because there was no vertical shift. So it's just -2 to 2. Okay. Now I'm going to get my inverse, and so I put y equal -2 cosine 7x. And to get the inverse, we want to switch x and y. So we get x equal -2 cosine 7y. And from there, we're going to have to work it out and solve for y. Any questions before we do that? Okay, so the first step would be divide by -2 because that's in front of here. So we get -x/2 equal cosine 7y. Then to solve for y, we need to do the inverse of cosine to both sides. So this is cosine -1 of -x/2 equal inverse cosine of cosine cancels, so you just get 7y here. And then we just bring this over and make it 1/7. That's the best form of the answer. And so that's what we're going to want for our inverse. So it's 1/7 cosine -1 negative x over 2. Some people put the fraction over a fraction, like this over 7, which was fine. But whenever they had a vertical shift, then they made an error. And so I would just recommend putting the 1/7 in front and just look at how the worksheet is also. Any questions? Okay. So again, if you just want to do a check on it, like to see if it's a reasonable thing, this was 7x, and that's multiplying 7 times x, so this is dividing, okay, 1/7. And this part was multiplying by -2, and this part's dividing by -2, so to speak. We like to have the negative on the outside or above, but you can think of that as dividing by -2 also. So that's how you can see how it works. When you have a vertical change, it's a little bit more complicated, but this one wasn't. Okay, so this one, you have secant of inverse sine of 2 squared of 5 over 11. So again, we're going to work inside out, and we're going to say sine theta equal 2 squared of 5 over 11. Remember, sine is the opposite over hypotenuse, which is the same thing as saying y over r. This is, I think, our first one today where you'd have to use the Pythagorean theorem. Once we figure out what quadrant we're in, we're going to end up using the Pythagorean theorem on this type problem. So let's see. Sine is positive where y is positive. And I'm saying it's positive because it's a 2 squared of 5 over 11. So both of those. But we know we're going to have to be in this quadrant because this is your interval for sine -1 from negative pi halves to pi halves. Okay, so now we know where we're going to be, and this is our angle, this is our opposite, the x-axis is where the adjacent is, and the hypotenuse is that. So we're going to put 2 squared of 5 on this side, and 11 for your hypotenuse. And we'll call the adjacent x. So we're basically using this inside to set up our triangle, and now we're going to do our Pythagorean theorem. So this is x squared plus 2 squared of 5 squared equal 11 squared. Also, if you want to think of it a little differently to make it easier, you could think of 2 as the square root of 4. And again, work backwards, so you can think of this as the square root of 20. So when we square the square root of 20, we're going to get 20. So that's how I can think about it, like using number sense. If you'd rather just type in 2 square root of 5, then press enter or control enter, then square it, you get 20. My concern is if you're doing it like this, and if you type it incorrectly, like this, that's not going to be right. If you do 2 times just the square root of 5 squared, that's wrong. But if you do 2 square root of 5, all of that squared, it's going to be right. You got to pay attention to where the parentheses is. Okay. All right. So we do get 20 here, and then 11 squared is 121. Then we're going to subtract. So x squared is 101. And then this one you get plus and minus the square root of 101. But since we're to the right of the x-axis, I'm sorry, to the right of the y-axis, we need to use positive. So this will be square root of 101. So again, that was to the right of the y-axis, so that's why we had to use positive. Now that our triangle is drawn, we need to do secant to the triangle. So apply secant to the triangle. So cosine was adjacent over hypotenuse, so secant was hypotenuse over adjacent. And so that's going to be 11 over square root of 101. And remember to rationalize that by doing square root of 101 on top and bottom. So that gives you 11 square root of 101 over 101. And that's going to be our answer. And let's just double check. So if we do secant of inverse sine of 2 square root of 5, go to the right, then divide by 11. That gives me this random decimal. And if I do 11 square root of 101 divide by 101, that gives me the exact same thing. Like every decimal place matches. And so that's how you can check your answer. Any questions? Okay. And then the last one for this video is number 9. We have sine -1 of -1. So if we do sine -1 of -1, that gives us negative 1.57. Which you may already remember. You can think of it again as sine theta equal -1, which is where your y value is -1. Because remember, sine relates to y. And this happens at 3 pi halves, which is also the same as negative pi halves. And so if we do negative pi halves, that gives you exactly what we wanted. So this is negative pi halves. Okay, that's going to be our stopping point for today.